Kia ora. Exponential expressions. Rules of indices, exponents, and powers. So they all mean the same thing. Here's our first example. P to the power of 5 times P squared. P to the power of 5 means P multiplied by itself 5 times, right? And P squared means P times P. So if we're multiplying them together, what do we get? How many P's are there multiplied together? We've got 7, so it's going to be P to the power of 7. And the shortcut we've learnt there is when multiplying, we add the powers. Second example, P to the power of 5 divided by P squared. Well, you've got 5 P's on the top line, 2 on the bottom, cancelling out. That would give us P to the power of 3. So our shortcut there, when dividing, we subtract the powers. So this is if the base is the same, obviously. Next example, 4P squared r to the power of 5, all cubed. So the all cubed means that what's inside the brackets is multiplied by itself 3 times. And then we look to simplify. So 4 times 4 times 4, we get ourselves the 64. P squared times P squared times P squared gives us P to the power of 6. And r to the power of 5 times r to the power of 5 times r to the power of 5 would be r to the power of 15. So our shortcut there, a fast way we could do this is when raising a power term to a power, you multiply the powers. So what that's talking about is that we could have gone 4 cubed would give us 64. P squared, so because it's 2 times 3, would give you the 6. And the r to the power of 5, 5 times 3, would give you the 15. So here's some examples for you to give a go. It would be great if you pause the video and then try these yourselves and then set to see if you got them right. I'll go through the examples now. So for the first one, k times k times k times k times k. How many k's have I got there? K to the power of 6. Example 2, m cubed times m to the power of 4 times m to the power of 1 times m squared. So that would give us m to the power of 10. Example 3. So looking there at the letters, we've got g squared, h to the power of 7, k squared, t squared on the top line. On the bottom line, g to the power of 5, h cubed, k to the power of 1, s cubed. So looking at simplifying each letter, that would simplify down to h to the power of 4, k, t squared, all over g cubed, s cubed on the bottom line. For the next example, where possible, it's good to try and simplify what's inside the brackets before you look to do anything else. So the first thing I'd do there would be to see that we could simplify down, and that would give us 2y to the power of 5z on the top line, all over 3w squared x on the bottom line. It's then that we look to use that power to the power of 4 there. So if you take everything to the power of 4, or if it's a term, you take the power of a power. So let's have a look. 2 to the power of 4 gives us the 16. Y to the power of 5, all to the power of 4 gives us, so multiplying those powers, y to the power of 20. Z to the power of 1, all to the power of 4 gives us z to the power of 4. On the bottom line, 3 to the power of 4, 81. W squared, all to the power of 4, so just multiplying the powers, w to the power of 8. And x to the power of 1, all to the power of 4, so 1 times 4 is x to the power of 4. At that point, you look to see, can you simplify this? And in this case, we weren't able to. So what I want you to do is to do some of these questions. It's saying just basically using a calculator to be able to answer them. So that would be great if you could look at that on page 271, exercise 18.01. And I've just said every question because they'll be quite fast, I think, for you to work through. All right, good luck.